A supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
The James Webb Telescope has just revealed new data about three I/A TLAS. But not everything is being shared with the public. This strange interstellar object is breaking scientific models, showing chemistry so bizarre that some astronomers suspect NASA is downplaying the truth.
A mysterious visitor is on its way to Earth, moving closer, 137,000 miles per hour. Is it an alien ship, a comet? Scientists and researchers are left puzzled.
Recently, certain images have gone missing from NASA official reports, raising questions. Could 3I/ATLAS hold signs of alien technology, or secrets too disruptive for the world to hear? For decades, discoveries like this have been shrouded in mystery. Join us as we uncover the shocking truths the James Webb Telescope has revealed about three I/ATLAS.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
Webb just caught an alien comet that breaks every rule we know. The James Webb Telescope reveals new data about three I/ATLAS that has left the scientific community in complete shock. On August 6, 2025, when Webb's powerful infrared instruments locked onto this interstellar visitor, they expected to see familiar water signatures that define every comet humanity has ever studied. Instead, they discovered something that defies explanation. The spectral analysis showed the highest concentration of carbon dioxide ever recorded in any cosmic object, with virtually no water vapor present. This impossible chemistry violates fundamental principles of how matter behaves in space. Even more baffling, the comet contains nickel while completely lacking iron, a combination that has never been observed anywhere in the known universe. Scientists are scrambling to understand how such an object could exist. The carbon monoxide, mysterious water ice formations, and carbonyl sulfide detected in its glowing coma create a chemical fingerprint so alien that researchers are questioning decades of established science. Carbonyl sulfide, the same compound that gives rotten eggs their distinctive smell, now floats through the vacuum of space in concentrations that make no sense. This cosmic anomaly represents the third confirmed interstellar object to enter our solar system, following the mysterious Oumuamua in 2017 and the more conventional 2I/Borisov in 2019. But 3I/ATLAS stands apart as something entirely unprecedented, a space breakthrough that challenges our most basic assumptions about cosmic chemistry. The near-infrared spectrograph aboard Webb captured light signatures that reveal this visitor's impossible nature. Each photon carries information about molecules that shouldn't coexist in the concentrations observed. The astronomical breakthrough represents years of theoretical work being overturned by a single observation session. But the James Webb Telescope reveals new data about 3I/ATLAS that goes beyond simple chemistry. The story of how this object came to exist challenges everything scientists believed about planetary formation around other stars. Cosmic forces have created an impossible mix of elements that contradicts every model of how comets should behave. But this chemical impossibility is just the beginning of a mystery that stretches back to the dawn of time itself. How did an object this ancient survive a journey that should have destroyed it billions of years ago? 7-billion-year-old time bomb racing past Earth. The ancient comet speeding past Earth carries materials older than our entire solar system. Scientific analysis of its trajectory reveals that 3I/ATLAS has been wandering through space for approximately 7 billion years, making it the oldest object humans have ever directly observed. This cosmic time capsule predates the formation of our Sun, planets, and everything familiar in our cosmic neighborhood by roughly 3 billion years. The interstellar visitor originated from the Milky Way's thick disk, a primordial region of our galaxy filled with ancient stars and stellar remnants from the universe's violent youth. This thick disk represents the galaxy's earliest stellar generation, formed when the cosmos was still settling into its current structure. Unlike our solar system, which exists in the galaxy's younger thin disk, this region harbors objects forged under conditions radically different from anything we understand. Racing through space at an incredible 220,000 miles per hour, 3I/ATLAS follows a hyperbolic trajectory that guarantees it will never return. This escape velocity means the comet isn't bound by our Sun's gravitational influence. It's simply passing through on a one-way journey back to the infinite darkness of interstellar space. Once it disappears beyond the reach of our telescopes, humanity will never get another chance to study this ancient messenger. The comet's epic journey through the galaxy exposed it to cosmic forces that would obliterate ordinary objects. During its 7 billion-year odyssey, it survived direct bombardment from supernova shockwaves that can sterilize entire star systems. It passed through stellar nurseries where massive stars were being born, enduring radiation levels that would vaporize planets. It navigated through dense molecular clouds where temperatures approach absolute zero, and matter exists in states impossible to replicate on Earth. Each encounter left its mark on the comet's structure and composition. The James Webb Telescope reveals new data about 3I/ATLAS, showing evidence of this cosmic weathering in its unusual chemistry. The radiation exposure and extreme temperature variations sculpted its current form over geological timescales that dwarf human comprehension. This interstellar messenger carries pristine samples of matter from the galaxy's primordial era. Unlike objects in our solar system that have been repeatedly processed through stellar generations, 3I/ATLAS preserves original materials from cosmic conditions that no longer exist. Its nucleus contains chemical signatures from an epoch when the universe operated under different rules. The comet's survival represents a cosmic miracle. Most objects ejected from their parent star systems billions of years ago would have been torn apart by gravitational encounters, destroyed by radiation, or pulverized by impacts with interstellar debris. The fact that 3I/ATLAS maintained its structural integrity throughout this impossibly long journey suggests it possesses properties that scientists are only beginning to understand. Yet the most disturbing aspect of this ancient wanderer isn't its age or its incredible journey. It's how cosmic radiation has fundamentally altered its very nature in ways that challenge our understanding of physics itself. The radiation-cooked mystery that's rewriting planetary science. The James Webb Telescope reveals new data about 3I/ATLAS, showing that billions of years of cosmic radiation have literally transformed this object at the molecular level. Scientists describe the comet as having been cooked by high-energy particles during its epic journey through interstellar space. This radiation bombardment created a protective shell around the nucleus that behaves unlike anything observed in comets from our solar system. The cosmic cooking process stripped away layers of the comet's original composition, potentially explaining why it shows such extreme carbon dioxide concentrations with virtually no water vapor. Normally, comets release water as their primary outgassing component when solar heating begins to sublimate their icy surfaces. The absence of significant water signatures suggests that 3I/ATLAS lost most of its original water ice during its radiation exposure over cosmic timescales. This radiation-induced transformation created a carbon dioxide fortress that resists normal thermal processes. Even as the comet approaches our Sun and experiences increasing solar heating, the expected water outgassing remains mysteriously suppressed. The protective shell appears to insulate the interior, preventing heat penetration that would normally trigger massive water vapor release. But researchers propose an even more mind-bending explanation for the comet's impossible chemistry. The interstellar visitor might have formed beyond the carbon dioxide ice line in its parent star's protoplanetary disk, a region so cold and distant that water never had the opportunity to condense into ice. In this scenario, 3I/ATLAS represents normal comet composition from an alien solar system with radically different formation conditions. The carbon dioxide ice line marks the boundary in a protoplanetary disk, where temperatures drop low enough for CO2 to freeze into solid form. Objects forming beyond this line would naturally contain higher concentrations of carbon dioxide ice relative to water ice. If 3I/ATLAS originated in such a region, its chemistry reflects the natural conditions of its birthplace rather than radiation-induced modifications. This possibility revolutionizes the understanding of how planetary systems develop around different types of stars. The James Webb Telescope reveals new data about 3I/ATLAS, suggesting that comet formation in other star systems might follow completely different rules than what occurred during our solar system's birth. Stars with different masses, temperatures, and evolutionary histories would create protoplanetary disks with unique chemistry and ice line distributions. The implications extend far beyond comet science. If objects like 3I/ATLAS represent typical building blocks from other star systems, then the chemical ingredients available for planet formation around other stars could vary dramatically from what scientists assumed. Planets forming from such exotic building blocks might develop atmospheric compositions unlike anything in our solar system. The radiation cooking theory and the exotic formation theory aren't mutually exclusive. The comet might have started with unusual chemistry from its alien birthplace and then been further modified by billions of years of cosmic radiation exposure. This double transformation would explain why its current composition appears so foreign compared to any object previously studied. Spectroscopic analysis reveals additional mysteries in the comet's chemical inventory. The presence of carbonyl sulfide in significant quantities adds another layer of complexity to its composition. This sulfur-containing compound typically forms under specific temperature and pressure conditions that don't match either formation scenario perfectly. But the most staggering revelation isn't just what this cosmic chemistry tells us about one alien comet. It's how these impossible ingredients could completely transform our search for life throughout the galaxy. Why this discovery could revolutionize our search for alien life. The chemical composition revealed by the James Webb Telescope's new data about 3I/ATLAS carries profound implications for understanding how life might emerge around other stars. If comets with such extreme carbon dioxide concentrations regularly delivered materials to young planets in other star systems, those worlds would have developed atmospheric chemistry fundamentally different from Earth's early conditions. Traditional searches for extraterrestrial life focus on planets with Earth-like atmospheric signatures, oxygen, water vapor, and methane in specific ratios that suggest biological processes. But if alien worlds received their initial atmospheric components from comets like 3I/ATLAS, they might harbour completely different chemical environments where life could thrive using entirely different biochemical pathways. The extreme carbon dioxide concentrations suggest some alien planets might have started with dense CO2 atmospheres, rather than the water-rich conditions that characterized early Earth. Life forms evolving in such environments would develop metabolic processes optimized for high carbon dioxide conditions. These organisms might be invisible to current detection methods that search for Earth-like biosignatures. Carbon dioxide-rich atmospheres could support exotic forms of photosynthesis that produce different waste gases than Earth's oxygen-generating plants. Instead of releasing oxygen, alien plants might emit nitrogen compounds, sulfur gases, or other molecules that current biosignature detection systems aren't designed to recognize. This means potentially habitable worlds could be hiding in plain sight, misclassified as lifeless because they don't match Earth-based templates. The presence of carbonyl sulfide in 3I/ATLAS adds another dimension to this possibility. Sulfur compounds play crucial roles in many biological processes, and worlds with sulfur-rich starting materials might develop life forms that incorporate sulfur into their basic biochemistry in ways unknown on Earth. Such organisms could create atmospheric signatures that appear purely geological to instruments designed to detect Earth-like life. Scientists working on Webb's observations are desperately racing against time to complete a full chemical inventory before 3I/ATLAS disappears forever. They're searching for additional organic compounds, including methanol, formaldehyde, methane, ethane, hydrogen cyanide, and ammonia. Each detection would provide crucial information about the chemical diversity available for planet formation in other star systems. The discovery of complex organic molecules in the comet's composition would suggest that the building blocks of life might be distributed throughout the galaxy in forms far more diverse than previously imagined. Rather than life requiring specific Earth-like starting conditions, it might emerge wherever sufficient chemical complexity exists, regardless of the specific molecular inventory. This paradigm shift affects how astronomers prioritize targets for detailed study with future telescopes. Planets orbiting stars in regions where objects like 3I/ATLAS originated might be excellent candidates for hosting exotic life forms, even if they show no Earth-like atmospheric signatures. The James Webb Telescope reveals new data about 3I/ATLAS that expands the definition of potentially habitable worlds. The comet's ancient age also provides insights into how long organic chemistry has been operating throughout the galaxy. 7-billion-year-old materials suggest that complex chemical processes have been creating and distributing organic compounds since the universe's early epochs. This extended timeline provides billions of additional years for life to emerge and evolve in environments we're only beginning to understand. Understanding the distribution and chemistry of interstellar comets becomes crucial for mapping the galaxy's habitability. If different regions of the Milky Way produce comets with distinct chemical signatures, then planets in those regions might cluster around specific types of atmospheric composition and potential biosignatures. The revelation that such exotic chemistry has been wandering our galaxy for eons raises an even more mind-bending question. What other impossible visitors have already passed through our cosmic neighborhood without detection? 3 mind-bending mysteries about our universe. The trilogy of confirmed interstellar visitors reads like a cosmic detective story, where each new clue deepens the mystery rather than solving it. Each object that has entered our solar system from the depths of space has challenged scientific understanding in completely different ways, suggesting that the universe contains far more diversity than anyone imagined. Oumuamua burst onto the scene in 2017 as humanity's first confirmed interstellar visitor, immediately breaking every rule about how space objects should behave. This elongated, cigar-shaped mystery accelerated away from the Sun, without showing any signs of the outgassing that typically causes such acceleration in comets. Its unusual motion sparked theories ranging from exotic hydrogen ice composition to speculation about an artificial origin. Scientists proposed it might be a fragment of a hydrogen iceberg, sublimating invisibly as it approached our star. The absence of detectable outgassing from Oumuamua, despite its clear acceleration, remains unexplained. Traditional comets accelerate when solar heating causes ice to sublimate, creating jets of gas that push against the nucleus. Oumuamua showed this acceleration without any visible gas production, leading to exotic explanations about molecular hydrogen sublimation or even more speculative theories about alien technology. 2. I/Borisov arrived in 2019, appearing reassuringly normal compared to its predecessor, displaying typical comet behavior with visible outgassing and a familiar chemical composition dominated by water and carbon monoxide. But even this normal visitor carried shocking statistics. It hemorrhaged water at a rate of 61 million gallons per second during its passage through our solar system. This massive water loss could drain Lake Superior in just a few hours. The scale of Borisov's water production revealed the incredible violence of interstellar comet encounters with our Sun. The comet shed enough water to fill 92 Olympic-sized swimming pools every second, creating a tail that stretched millions of miles behind it. Despite appearing more familiar than Oumuamua, Borisov's behavior demonstrated that even normal interstellar objects operate on scales that dwarf anything seen in our local comet population. Now the James Webb Telescope reveals new data about 3I/ATLAS that shatters expectations once again. This third messenger combines the chemical impossibility of extreme carbon dioxide concentrations with the ancient pedigree of 7 billion-year-old materials from the galaxy's primordial epoch. Its radiation-scarred surface tells a story of survival through cosmic conditions that would annihilate ordinary objects. Each visitor represents a different type of solar system and a different pathway for cosmic evolution. Oumuamua might originate from a system where exotic ice compositions form under conditions unlike anything in our cosmic neighborhood. Borisov could represent massive comet populations in systems with abundant water ice formation. 3I/ATLAS arrives from ancient stellar regions where carbon dioxide dominated the chemistry of planetary formation. The pattern emerging from these three encounters suggests that interstellar space contains a vast population of wandering objects, each carrying chemical signatures and physical properties that reflect the incredible diversity of stellar environments throughout the galaxy. Rather than rare curiosities, these visitors might represent the tip of an iceberg of cosmic diversity that has been invisible until now. Statistical models suggest that dozens of interstellar objects pass through our solar system every year, but most remain undetected due to their small size or dim appearance. The three confirmed visitors were discovered only because they passed close enough to Earth and were large enough to reflect sufficient sunlight for detection. Countless others have likely passed through unnoticed, carrying their own unique stories and impossible chemistry. The James Webb Telescope reveals new data about 3I/ATLAS that hints at this hidden population. If one randomly detected comet can carry such exotic chemistry, then the interstellar medium must be filled with objects representing every possible combination of stellar formation conditions, radiation exposure, and chemical evolution that has occurred throughout the galaxy's history. Future detection systems specifically designed to find interstellar visitors will likely reveal a parade of cosmic messengers that challenge scientific understanding in ways we can't yet anticipate. Each new visitor will carry information about stellar systems, planetary formation processes, and chemical evolution pathways that exist nowhere in our local cosmic environment. The diversity already revealed by just three objects suggests that the universe operates according to principles far more varied and complex than models based solely on our solar system could predict. 3I/ATLAS, with its impossible chemistry and ancient origins, represents just one example of cosmic evolution pathways that have been operating throughout the galaxy for billions of years. This cosmic parade of impossible visitors forces a fundamental question about our place in the universe. If such exotic objects regularly wander between star systems, carrying chemistry and physics that challenge our basic understanding, then what other cosmic processes remain completely unknown simply because they haven't happened to pass close enough to Earth for detection? The James Webb Telescope reveals new data about 3I/ATLAS, showing that each interstellar messenger is rewriting scientific textbooks in its own unique way. The universe appears to be far stranger, more diverse, and more creative than humanity ever imagined. These three visitors have opened a window into cosmic processes that operate on scales of space and time that dwarf human experience, revealing that our cosmic neighborhood is just one small example of the incredible variety that exists throughout the galaxy. The mystery deepens with each discovery, suggesting that the universe's capacity for creating impossible objects and exotic chemistry extends far beyond what current scientific models can predict or explain. 3. I/ATL. AS may be the most shocking visitor yet, but it likely won't be the last to completely overturn established scientific understanding about how the cosmos actually works. So, what do you think? Is 3I/ATLAS really just an interstellar comet, or could it be carrying something far more advanced than we've been told? And if NASA is holding back details here, what else might they be keeping from us? Share your thoughts with us in the comments section. And the story doesn't end with 3I/ATLAS. Another strange Webb discovery may be even more unsettling. Check out our next video and you will be shocked